Hello everyone, my name is Deepika Sharma and today my topic of the presentation is scheduler, its type and performance measure parameters. So the main topics that I'm going to covered in this PPT are: this presentation is about how to get a process attached to a processor, and the second point is the design of a scheduler is concerned with making sure all users get their fair share of resources. And next is types of schedulers, in which we have long, medium and short term scheduler, and the different parameters to measure the performance of CPU scheduling. So first of all, what is CPU scheduling? The process scheduling is the activity of the processor manager that handles the removal of running processes from the CPU and the selection of another process based on a particular strategy. So what actually happens, every process running on the system needs input, output and other system resources in addition to processing. So a processor waits for the completion of input-output activities for a particular process and then start its processing. The concept of scheduling during the time the input-output activities related to a particular process are being performed, the operating system gives the control to the processor to some other ready processes. So in this way the processor is kept busy in processing all the time. This leads to a greater efficiency of the system. And scheduling is mainly important in multitasking operating system, as I already explained in my previous PPTs, in which multiple jobs are processed simultaneously by the processor on time sharing basis. So process scheduling is an essential part of multi-programming operating system. Next is scheduler. First of all, scheduler. A scheduler is an operating system module that selects the next job to be admitted in the system and next process to be executed by the CPU. Selects from among the processor in memory that are ready to execute and allocate the CPU to one of them. And CPU scheduling decisions may take place when a process first switches from running to waiting state, second case switches from running to ready state, third switches from waiting to ready state, and last terminates. Now here is the process scheduling queue. In operating system mainly we have three types of queues in scheduling. First is batch queue, then ready queue, then suspended queue. First of all, batch queue. This queue keep all the processes in the system. Ready queue, the main objective of this queue is to keep a set of all processes residing in main memory ready and waiting to execute. A new process is always put in this queue. And last we have suspended queue that contain the processes which are blocked due to the unavailability of an input output device constitute this queue. As we can see in this image that first of all we have batch queue. It contain all the processes, then it shifts the jobs to the and the processes to the ready queue, which contain the which have all the resources and that are waiting for the CPU. And from here the ready queue forward the processes to the CPU for processing. Out of them, if some of the processes have lack of input and output devices or other resources, then that process may shift it to the suspended queue. Now next, scheduler. um, as I already explained, scheduler are special system software which handle process scheduling in various ways. Their main task is to select the job to be submitted into the system and to decide which process to run. Schedulers are the are of main three types. First is the long term scheduler, second is short term scheduler, then medium term scheduler. Now I'll explain what is long term scheduler. Long term scheduler is also called job scheduler, and long term scheduler determines which programs are admitted to the system for processing, and it selects processes from the queue and loads them into memory for execution. Like, long term scheduler mainly works with batch operating system. In this, a batch of jobs is submitted for execution. These jobs are stored in a batch queue. The long term scheduler selects next batch queue for execution when the execution of a batch of jobs is over. So a batch usually contains resource, comma, low priority programs that are used to utilize the processor at the time of low activity of the system. Batch job contains all necessary data and commands for their execution, so that it needs an estimate of their resource needs, for example memory size and execution time, etc. And the main objective of long term scheduler is to provide batch jobs in such a manner that the processor and the input output remains busy at all the times. That means when a processor utilization is low, the long-term scheduler provides more processor bound jobs, and when processor is busy, it provides more input output related jobs. A long-term scheduler is invoked when a complete batch of jobs go out from the system. And the primary objective of job scheduler is to provide a balanced mix of jobs, such as input output bound, the processor bound. It also controls the degree of multi-programming. So long term scheduler is the first step in in CPU scheduling, and it performs very important activities to send the processes to the ready queue. Now, next is multi medium term scheduler. In medium term scheduling, or scheduler is a part of swapping. It removes the processes from the memory. It reduces the degree of multi-programming. The multi-term scheduler is in charge of handling the swapped out processes. Medium, I'm sorry, it's medium term scheduler, and medium term scheduler handles the swapped out processes and make them ready for execution. After execution for a while, a running process may become suspended due to an input output request or a particular system call. The suspended processes are removed from the main memory so as to save space for ready processes. The suspended processes are stored in the secondary memory. Once the suspending condition is removed, it is the job of the medium term scheduler to allocate the required amount of memory and swap the processes to make them ready. In this way, medium term scheduler is provided with the information about the memory requirement of a swapped out process. It keeps the record of memory requirement of the swapped out processes. This is done by using process control blocks. The medium term scheduler handles process transitions from suspended to ready state, and the medium term scheduler is more frequently invoked than long term scheduler, and it is less frequently invoked than short term scheduler. And next we have short term scheduler. In short term scheduler, it is also called CPU scheduler. The main objective is to increase system performance in accordance with the chosen set of criteria. It is change of ready state to running state of the process, and the CPU scheduler selects a process among the processes that are ready to execute and allocates CPU to one of them. And in short term scheduler, it allocates the processes among the pool of ready processes, right? So the objective of the short term scheduler is to maximize the system performance as per the predetermined criteria. Short term scheduler must be involved with each process switch. Here the switching of a processor from one to other process. Switching refers here for this, so as to select the next process to run, but practically the short term scheduler is invoked in response to every event that leads to change in global system state. And now we have what is a global system state. So the global system state is the collective state of all processes and resources in a system is regarded as global system state. And clock, interrupts, input output, completions, and operational calls are the few examples of the events which change the global system state. On occurrence of any of these events, the operating system calls the short term scheduler to decide which process should be scheduled for execution. The short term scheduler handles process transition from ready to running state. And all these points are explained in this diagram, how all these three schedulers works. And so this is all about the types of schedulers, and here is the comparison of types among the types of scheduler. First is the long term scheduler, and second is the short term scheduler, and third is the medium term scheduler. As I explained, long term scheduler is also called job scheduler, short term CPU scheduler, and medium term is called process swapping scheduler. And next is about the speed. Speed is lesser than short term scheduler in long term. In short term, speed is fastest among other two, and in medium, speed is in between both short and long term scheduler. And next about the degree of multi-programming. It controls the degree of multi-programming in long-term scheduler first, and in short-term scheduler it provides less control over degree of multi-programming, and medium-term scheduler it reduces the degree of multi-programming. And next, in long-term scheduler it is almost absent or minimal in time sharing system, and in short term scheduler it is also minimal in the time sharing system, and medium term scheduler is a part of time sharing systems. And the last point is, in long term scheduler it selects processes from pool and loads them into memory for execution. And what short term scheduler, it selects those processes which are ready to execute. And medium term scheduler it can reintroduce the processes into memory and execution can be continued. So this is all about scheduler and its type and the comparison of scheduler. Now the next topic of presentation is what are the different parameter. On the basis of that we can assume that our scheduling algorithm and scheduling processes are best. So the scheduler maximize the system performance by scheduling multiple jobs for a single central processing unit. The schedulers use some performance measures and optimization criterias to maximize the system performance, and these parameters to judge the performance of the schedule of CPU scheduling are processor utilization, throughput, turnaround time, waiting time, and response time. Now I'll explain all these five parameters. So first is the processor utilization. In processor utilization, a processor, we all know, our processing unit where all our processes executes its functions. So the processor utilization is the average fraction of time during which the processor is busy. For the word busy, we mean that the process is either executing the user processes or operating system processes, because we have mainly two types of processes or two types of main processes that we submit on the processor. First is the user processes that are on user demands, and second is the operating system processes. Processor utilization is generally measured by using a null process that runs when no other process is running. Process utilization should be range from 40% for a lightly loaded system to 90% for a heavy loadily system, and it is one of the main parameter to measure the performance of our scheduling algorithms. And next parameter we have throughput. Throughput refers to the amount of work completed per unit time. As we all know, when we buy some of other system and any other machine, then throughput is the main parameter that gives us the average of work done in a specific time. So one way of expressing the throughput is by means of the number of user jobs executed in unit time. Unit time means we have to measure the performance with respect to a fixed time. Higher the number, more is the work done by the system. And in closed environments such as real time system, scheduling can be treasure of efficiency. In system where services are required by a number of users, for example time sharing system, throughput is determined by external factors, and it is a friction of request arrival time and processor service time. And next parameter we have turnaround time. It is the time which passes from the moment a program or job was submitted to the system till it is completed by the system. Turnaround time is the total time spent by the system in processing a job, and we can also say it is the sum of waiting and execution time. Now what is waiting time? Waiting time is the total time spent by a processor while it was waiting for resource allocation due to contention with the other in a multi-programming system. Waiting time is actually a difference of turnaround time and actual execution time, because in turnaround time it is the sum of waiting and execution time. So if we subtract the execution time from the turnaround time, then the all remaining time is the process waiting time. And last we have response time. Response time in interactive systems is the time elapsed for the moment the last command line character was typed and the first result appeared on the terminal. This is usually called as the terminal response time, and in the case of real time systems, response time is the time elapsed from the moment any internal or external event occurs till the first instruction of the respective service routine is executed. This is generally called event response time. And in addition of these factors, a scheduler should also have fairness, predictability, and repeatability so that the similar workloads exhibit similar behaviors. Because performance evaluation and these parameters, the overall performance of a computer system depends upon how it schedules resources into multiple running processes. So the scheduler should effectively manage all the system resources like memory and the input output devices in such a manner that each of the process gets fair processor time and almost equal response time. Practically, the choice of scheduler is made by using specific knowledge about system and the and in other ways, if we want to check the performance evaluation, simulation and queuing model are the most common tools used uh, for our performance evaluation of a particular system. So this is all about the types of schedulers and the parameters that we use to measure the performance of scheduling in our CPU and the scheduling performance of the particular algorithms. Thank you.